in a pramp interview today, and the question I got was an H-tree construction. Essentially, is you should want to get a Python program to draw out um, drawing H's like this with the length 1, length 1, length 1, length 1, or just length X or whatever is consistent. And then if you wanted to add more, and there's depths, so that's one depth, so there's one H. If you want to go 2 depths, that means each point here we get an H2 with the center line like this. And then if you want to go depth 3, that means each one of these, so there'll be 4 spots times 4 triangles would be 16, not triangles but H's, that'd be 16, so I have to draw 16 more H's, and then depth or so on and so forth. So it kind of has a recursive little tune to it. So my first general thought was get a function here. Yeah, I was supposed to right here too. We're not actually going to be drawing out anything. We're just going to be feigning that, or just not feigning it, but simulate by just printing out the args for draw a line when you draw a line. So here's the actual driver method. It takes the x and y coordinate, what you want to draw, an h, so it'll be the center. So if this is 0, like y-axis, x-axis would be 0s over here. The length of what your h's you want to be, and the depth, if you want to go 1, 2, 3, and 4, and so on. And there's another last part of this. And there's also a variable called like the dividing reducing ratio. That means this main one on depth 2 is like if this is 1, for this instance they use it, you want to scale it down divided by pi of 2, or I mean square root of 2. Apparently that just is a good ratio, just to have it pretty looking. But yeah, so if it's recursive by nature, it's pretty apparent. You have a base case, so if depth once equals 0, that means you're done, you just want to return it. If not, then you just want to practice drawing out the lines. So the first thing we want to do is just draw the horizontal line. And since this is the center point, we want to do half the length. We want to draw this part here. So can I do this in a different color? I can't. But so what you want to do is, if this is 0 point, what you want to do is, if you can barely see it, since this just say the length is 2 in this case, you want to do half of x, which is just this line here. You can kind of see right there, and just draw that line. Then we're done with that, then draw this line. And from there, draw this line, then draw this line, draw this line, and draw this line. So we have 1, 2, 3, 4, 5, 6 different calls of drawing line. Actually, what I did was you just draw this line there. I said that wrong. You're not going to call draw a line that many times. This is not working. You just want to draw essentially this line right here, then this one, so you call it 3 times for each time when you draw H tree. So, and then like when you get the second depth, you want to just draw there, there, and there, but then you want to reduce it though. Yep, so you draw a line from, pretty much, yeah, you have to divide the length by 2. The y coordinates stay the same to get the horizontal, and for the vertical ones, I just made these helper, kind of makes it a little bit easier to read, helper variables. That the very right x coordinate is going to be your x position plus another half the length, and then and then you want that's going to be static then, and then for the right vertical coordinate you want to have, since these are going to be different, you have to have a y plus a half a length and minus a half a length, and you just draw your line. So this right coordinate's here, because that's going to be fixed because you start from this point essentially, And you want to draw from up here to up here. And that's what this line's kind of doing, saying. So draw from the top, I guess. Draw from the top to the bottom. And then on the left side, do the same thing. Draw from the top to the bottom. And then you're done drawing those. So now you just want to do a recursive call. So it's just called draw H tree again, but then you have to rename your variables for each of the points. So your starting points are going to be here, 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 and here. And those are right there. So these two, the left y bottom coordinate and the right vert. So this one refers to that one, and then this one, this recursive call will refer to this one. And then the lengths are just going to be, then you have to decrement your lengths by a ratio of square root to 2, and then, whoops. You want to decrement your depth 1, since you're working away your depth total is 0. So if you start at 3, you would get to 0, and then you just hit this return, which it breaks out of the function. Yeah, so here's the same code, and essentially this will spit out. So we're going to start at the center, the origin of the xy coordinate. We're going to give the starting length is going to be 2, and then we're just going to print out 1, h. So what's going to do is print out all the times we call draw line. So we should expect 3 lines drawn, right? We should expect this line drawn, this line drawn, and this line drawn. Yep. So say it would draw a line from to the very left to the right, all on the x-axis, and then it would draw the very top right to the very top bottom right, and then top left to the bottom left, right? So now just say if we want to make the depth 2, I suppose this doesn't have to be a float. We're going to want this recursive call grows a let me get rid of this. Yeah, it grows exponentially. So equal to 1 to 5. I think this is the 15, and it's just going to keep getting bigger. So we're going to call 15 different draw line calls here, right? Since there's 15 lines. Well, each h has 3 line calls, right? Draw line here, here, here. So then there's how many h's? 1, 2, 3, 4, 5. So 15 would be here. And how many h's are here? Well, that's a lot to count. But so on the depth of 2, though, we should see 15 line drawn count. So it's 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. Yep. And these will be all the coordinates that the lines would be drawn at. As you can see, there's big decimals because, or long decimals because of the factor of square root 2. But if we change this to like, hold on here, we could also have another variable called ratio decrement would equal length divided by, then they could just do this, let's just do it, say a half. This should work here. Now this will be a little bit prettier. Yeah, so now we can see halves instead. Since we're starting with 2, we're only going to get units of 1. So you can see stuff like that. But yeah, now this will be 15 call. And then if we do this, if we want to get 3 levels, how many times is that going to be? It's going to be a lot more. See, yeah. And if we do 4 more, it just grows exponentially. Yeah, look at all that. So many line drawings. But yeah, that's how you do it recursively, and that's kind of a fun problem to work on.